When most junior engineers first open Approved Document F, they usually know one thing. It has something to do with ventilation. The problem is that this is nowhere near enough to design properly. What you actually need to understand is what the document is trying to achieve, which sections matter most to you, which airflow rates you are expected to know, how to calculate the whole dwelling rate correctly, and what common design mistakes will catch you out later in coordination, commissioning, or site inspections. This video is focused on Approved Document F, Volume 1, Dwellings, 2026 edition. Before we go any further, there is one important caveat. This is the latest published edition, but it is not the same thing as already in force on every live job. The 2026 edition takes effect on 24th March 2027 for most building work not connected with higher risk building work, and 24th September 2027 for building work connected with higher risk building work, subject to the transitional provisions. So for real projects, always check which edition is actually applicable to the job. At a high level, Volume 1 applies only to dwellings. The document states that its guidance applies only to dwellings, and for blocks of flats with shared communal rooms, you should also consult Approved Document F Volume 2 for the non-dwelling parts. That distinction matters a lot in mixed-use and residential-led projects, because one of the easiest mistakes for a junior engineer is to assume one volume covers the whole building. It doesn't. Volume 1 is the dwelling side guidance. The first place I would tell any early career mechanical engineer to focus is Section 1, especially the logic behind the ventilation strategy. The document says the example systems in the approved document are just that, examples, and that other systems may be acceptable if they can be shown to meet an equal level of performance. It also says that performance criteria for acceptable levels of moisture and pollutants are given in Appendix B. That matters because it tells you something fundamental about how to read Part F. The tables are not the whole story. The real job is to achieve the required ventilation performance in the actual dwelling. For a junior mechanical engineer, there are 5 technical areas in this document you absolutely need to understand. The first is extract ventilation rates. The second is whole dwelling ventilation. The third is air transfer through the dwelling, including door undercuts and internal airflow logic. The fourth is purge ventilation. The fifth is installation, testing, commissioning, and information to the homeowner. Let's start with extract rates, because these are the numbers many people learn first. For intermittent extract systems, paragraph 1.15 points you to table 1.1. The minimum extract rates are kitchen with a cooker hood extracting to outside 30 liters per second, kitchen with no hood ducted outside, or where the hood does not extract to outside, 60 liters per second, utility room 30 liters per second, bathroom 15 liters per second, sanitary accommodation 6 liters per second. That immediately gives you one important practical warning. A recirculating cooker hood does not let you use the lower 30 liters per second kitchen figure that is specifically tied to a hood extracting to the outside. If the hood is not extracting to outside, the kitchen falls into the 60 liters per second case. That is exactly the kind of thing that gets missed when someone copies a schedule without reading the room definition properly. For continuous extract systems, paragraph 1.18 and table 1.2 are the key references. The minimum high rates are kitchen 13 liters per second, utility room 8 liters per second, bathroom 8 liters per second, sanitary accommodation 6 liters per second. The table also states that the sum of all extract ventilation in the dwelling on its continuous rate should be at least the whole dwelling ventilation rate given later in paragraph 1.20 and table 1.3. That is one of the most important logic links in the whole document. Continuous extract is not checked room by room in isolation. The system also has to satisfy the dwelling total. Now let's come to the part that a lot of juniors struggle with most: how to calculate the whole dwelling airflow properly. Paragraph 1.20 is the key paragraph, and this is one you should genuinely remember. It says the minimum whole dwelling ventilation rate for the supply of air to the habitable rooms should meet both of the following conditions. First, a minimum of 0.3 liters per second per square meter of internal floor area. And second, a minimum rate determined by the number of bedrooms, as given in Table 1.3. The bedroom table gives 1 bedroom 19 liters per second, 2 bedrooms 25 liters per second, 3 bedrooms 31 liters per second, 4 bedrooms 37 liters per second, 5 bedrooms 43 liters per second, and then add 6 liters per second for each additional bedroom beyond 5. There is also a note that if the dwelling only has one habitable room, a minimum of 13 liters per second should be used. The easiest way to teach yourself this is with a rule: required whole dwelling rate equals the greater of 0.3 times internal floor area and the bedroom-based minimum in Table 1.3. That is the rule you should come back to again and again. Let's do a worked example. Take a 2-bedroom flat with an internal floor area of 82 square meters. Method 1, floor area. 0.3 times 82 equals 24.6 liters per second. Method 2, bedroom method. A 2-bedroom dwelling gives 25 liters per second. Now compare the two. 24.6 liters per second versus 25 liters per second. The required whole dwelling ventilation rate is 25 liters per second because paragraph 1.20 requires you to satisfy both conditions, so in practical design terms, you use the larger value. Now imagine you are using a continuous extract strategy. You still need each wet room to satisfy its minimum high rate from Table 1.2. But on top of that, the sum of the continuous rates across the dwelling needs to be at least 25 liters per second in this example. So if you had one kitchen and one bathroom, your high rates might be 13 liters per second and 8 liters per second when boosted. But the design also needs to be arranged so that the total continuous operation achieves the whole dwelling rate required by paragraph 1.20. That is the sort of logic that separates "I know the table" from "I understand the ventilation strategy." The next area juniors need to understand is air transfer through the dwelling. Part F is not just about terminal rates, it is about how air actually moves. Paragraph 1.21 says internal doors should allow air to flow through the dwelling by providing a minimum free area equivalent to a 10 mm undercut in a 760 mm wide door. It then says doors should be undercut to achieve either 10 mm above the finished floor or 20 mm above the unfinished floor surface. This matters because your strategy can look perfect on paper, but if there is no realistic transfer path between habitable rooms and extract rooms, your design logic is broken. The next thing to watch is background ventilators. The 2026 edition says at paragraph 1.64 that where continuous mechanical extract ventilation is used, background ventilators should satisfy the conditions in that paragraph, and the associated checklists later in the document reinforce this. The Future Homes Standard Assessment Note, published by government, also explicitly references section 1.64 as setting a minimum background vent area of 4,000 square millimeters for each habitable room for continuous DMEV and CMEV checking. That same government assessment note also states that for MVHR, the dwelling is checked against the whole dwelling ventilation requirement, and it flags the Part F rule that background ventilators should not be installed with MVHR. That leads to one of the cleanest design warnings in the whole document. Paragraph 1.72 says background ventilators should not be installed with mechanical ventilation with heat recovery to avoid unintended air pathways. So for MVHR, do not casually leave trickle vents in because more ventilation is safer. In the Part F logic, that is the wrong approach. You also need to understand purge ventilation. The 2026 document keeps purge ventilation as a core requirement and cross-refers to the purge section from later system-specific guidance. The natural ventilation table and checklist references show that rooms still need a purge route, typically windows or equivalent openings directly to outside, and the 2021 enforced structure used the familiar benchmark of opening size to provide purge ventilation equivalent to around 4 air changes per hour per room. The 2026 edition continues to carry purge ventilation as a distinct part of the dwelling strategy via paragraphs 1.22 to 1.27 and the associated table references. So if I were teaching a junior engineer how to sense check a dwelling ventilation design quickly, I'd say check it in this order. First, identify the system type: intermittent extract, continuous extract, MVHR, or another justified performance-based route. Second, check the room-level extract rates against Table 1.1 or Table 1.2, depending on system type. Third, calculate the whole dwelling rate using paragraph 1.20 and Table 1.3. Use the larger of the floor area method and bedroom method. Fourth, check the air path: habitable rooms supplied, wet rooms extracted, realistic transfer through the dwelling, and internal door undercuts in line with paragraph 1.21. Fifth, check the system-specific background ventilator logic. For continuous mechanical extract, follow paragraph 1.64. For MVHR, remember paragraph 1.72, no background ventilators. Sixth, check purge ventilation and whether the dwelling still has a sensible route for rapid ventilation when needed. Seventh, think about commissioning and information handover, because Part F does not stop at drawings. That brings us to the site and commissioning side, which is one of the most useful parts of the document for someone starting out. The 2026 edition has a more developed Section 4 and appendices structure around installation, certification, inspection and testing of mechanical ventilation systems, airflow rate testing and commissioning, inspection standards, operating and maintenance instructions, and completion checklist and commissioning sheets. The table of contents makes this very visible, and the revised 2026 circular says the updated guidance includes clearer routes for certifying fixed building services installations and setting out available enforcement options where work does not meet the required standards. It also says updated guidance covers the commissioning and installation of fixed building services and introduces Regulation 40C requiring provision of information to homeowners of new dwellings in an appropriate format. Compared with the earlier 2021 edition, the latest published 2026 edition is tied into the future homes and building standards changes and introduces a stronger emphasis on certification, inspection, testing, commissioning, enforcement routes, and information provision to homeowners, including the new Regulation 40C reference. The circular letter also says the revised guidance includes routes for certifying fixed building services installations and setting out enforcement options where work does not meet the required standards. In other words, the latest version pushes even harder on the idea that compliance is not just what is shown on the drawing. It is also about how systems are installed, checked, certified, and handed over. That matters for a young mechanical engineer because it changes how you should think about your role. You are not just selecting fans and copying rates into a schedule. You are designing a system that someone has to install, measure, commission, certify, and explain to the end user. The latest edition makes that real-world performance chain more explicit. Let's finish with the most common mistakes. The first is treating extract rates as if they are the whole design. They are not. The second is calculating the whole dwelling rate wrongly by using only bedroom count or only floor area instead of checking both and taking the governing value. Paragraph 1.20 is the key check here. The third is forgetting the air transfer path through the dwelling. A design with no real transfer route is a bad design even if every room schedule line looks compliant. Paragraph 1.21 is the reminder. The fourth is using the wrong background ventilator logic for the system type, especially leaving background ventilators in with MVHR despite paragraph 1.72. The fifth is using the wrong volume on mixed-use projects. Volume 1 is for dwellings. Shared communal rooms fall into the Volume 2 side. And the sixth is forgetting that the 2026 edition strengthens the practical emphasis on certification, inspection, testing, commissioning, and homeowner information. That is not just admin. It is part of delivering a working ventilation system. So if you remember this whole document in one technical sentence, remember it like this. Approved Document F Volume 1 is not just a list of fan rates. It is a dwelling ventilation strategy document that requires you to get room-level extract, whole dwelling airflow, transfer air, purge ventilation, system-specific vent logic, and commissioning all working together in the real building.